Okay, we're going to look at dividing a polynomial by a monomial. So right here we have 36x cubed plus 12x squared minus 20 being divided by 4. And so what we're going to do is divide each of the individual terms in the numerator by 4. So let's do that. Okay, so this should be fairly simple. 36 divided by 4 would reduce down to 9x cubed. Then the 12 divided by 4 would reduce this down to 3x squared. And then 20 divided by 4 is 5. So that's what we end up with on our first one. On the next one, it gets a little bit more interesting because we're going to divide everything by 3y. So let's see what we have going on here. So 24y squared divided by 3y, then 3y divided by 3y, and then minus 24 divided by 3y. So we're going to have to remember our properties of exponents here. So the 24 and the 3 are going to work the same way as the first problem. So 24 divided by 3 would be 8. But then here what you do is you subtract the denominator power from the numerator power if you have the common base, which we do of y. So we're going to have y to the power of 2 minus 1. Then here you basically have 3y divided by 3y. So whenever you have something divided by itself, you have the same exact thing on top and bottom. That's just going to reduce down to a 1. So the 3's cancel and the y's cancel, but technically they're going to reduce down to a 1. Then minus 24 divided by 3. Well, what's going to happen is, see, the 3 will reduce to a 1 and the 24 to an 8, but the y is going to be stuck in the denominator spot. So we're going to end up with 8 over y. So this third term is going to stay a fraction right here. And then the last thing I have to do is clean this up on that first term, which you could have done in your head if you felt comfortable with that. And actually, I'm just going to go ahead and write it as 8y. The 1 is understood, so it's not necessary to write that power right there. And so there we are. Okay, let's try another one. And so on this next example, let's see, we're going to divide everything by 4y cubed. Well, my first term is 4y cubed, so that will just simplify into a 1 in a moment. Then let's see, we got 20y squared divided by 4y to the power of 3, then minus 20y divided by 4y to the power of 3. Okay, so I'm going to kind of maybe approach this one a little different than the last one. The first term, though, is identical to what happened on the previous one. This should just simplify into a 1. Right here, the 20 over 4 would reduce down to a 5, or I'm going to put it as 5 over 1 for a moment, okay? Because when I look at the y's, if I want to do the quotient rule, which I did on the previous example, I would have to subtract the 3 from the 2, and I'd get y to the power of negative 1, which is fine if that's the way you want to do this. But as we get more comfortable with working with exponents, what we want to realize is that I can cancel these two out with 2 of those, and it would leave me with 1 y in the denominator spot. So this really would simplify into 1 over y, and we'll clean that up in a minute. And then I'm going to kind of have a similar thing happen here. So 20 divided by 4 is also going to be that 5 over 1, or just 5. And then this understood 1 right here, this y, I'm going to cancel this y with one of the y's here, because what's going on is y to the power of 3 is really y being multiplied together 3 times. And so what we're doing is we're canceling one of those with one of these, and it leaves me with 2 of them left behind. And so that's why I have a y squared left over in my denominator spot. So the last thing I want to do is just kind of clean this up, make it look a little bit nicer. So let's see, we're going to have 1 plus, this would just become 5 over y, minus 5 over, and then I'm going to put the y squared right there. Okay, my last example, we are going to divide the polynomial by negative 3x squared. And so that negative 3 is going to make things a little interesting. It's just going to cause a sign change for each one of my numerator terms. So here we go. Let's see, we have 9x to the power of 5 over negative 3x squared plus 27x to the power of 4 over negative 3x squared minus 27x squared over negative 3x squared. Okay, so looking at the first part, so just take each term individually and kind of break it into a smaller problem. So just focus on one at a time. So 9 divided by negative 3 would become a negative 3. Then these two will cancel out with 2 of the 5 that are on top. So I'm going to cross that out. That would reduce that down to 3. So I have x cubed. And so everything got canceled out in my denominator spot. The negative 3 came from the 9 divided by negative 3. That's how I got that. And then, like I said, we canceled out the x squared with 2 of them on top. Left me with x cubed. Okay, my next term, let's see, I have plus, and then let's see, 27 divided by negative 3 would be a negative 9. And then these two will cancel out with 2 of those on top to where I'll still be left with an x squared. And so you'll notice that I have plus a negative 9x squared, which we'll simplify that in a moment. Then on my last one right here, let's see, we've got minus, and then let's see, 27 over negative 3 again, that's going to be a negative 9. And then the x squared divided by x squared, what happens is they basically cancel out, they turn into 1s. And so you're basically multiplying by a 1 here. If you want to put that there, that's fine. It's not really necessary, but that's what happens. And then we just want to clean this up a little bit. So let's see, we have our negative 3x cubed. And then if adding a negative, we're going to go ahead and change that to minus 9x squared. So whenever you're simplifying, less is more. So the less you have written on your paper, the more simplified it's considered to be. So then we're going to have a similar thing happen here. So I'm subtracting a basically negative 9 times 1. So if you subtract a negative, that's the same thing as saying plus 9. So the double negatives turn into addition right there. And that's my final result for that one.